Hi everyone, welcome back. This is Charishma from Triple Department, and I'm dealing with the subject of database management system for current semester. So, in previous session, we have looked into the basics of a database management system, like what is a data, what is meant by database, what is the use of maintaining a database, the concept of view of data, and what are the different types of data models we have, and what are the different data languages we have, like data definition language, data manipulation language, and data control language. And also, we have seen looked into the concept of abstraction along with database instances and schema. At the end, we have looked into the overall architecture of a database. Now, in this session, we'll get into the actual concept of the relational database. As we spoke, relational database is a kind of a database like we have a list that has been discussed in previous session. Among those, I said relational database is said to be the most important kind of database because you default consider a relation or table when people speak about database, they by default they consider it as a table. That is like you're storing your data in the form of a table. So let's get into the session. So in today's session, we'll be looking into the concept of what is meant by a relational database, what are the components of relational database, and how to write queries for SQL, and what is meant by a relational algebra, what is the role of relational algebra in the concept of structured query language, that is SQL. And we also going to look into the concept of keys, which is said to be very important topic of relational database, and what is the role of key in relational database. So, what is meant by relational database? Let me tell this concept in a very simple manner. Relational database is nothing but storing your data in the form of table. So, what is meant by table? Table is nothing but the combination of rows and columns. In general terminology, we usually use the table components as rows and columns, but when you speak about relational database, we have a specific names given for rows and columns. So, the rows here, you can see in the table, the rows are called as the tuples. The rows are called as the tuples. So all the row elements are called as tuples. That means the tuples are going to carry out complete record of any entity. Complete record. Like you see, I have a name Ronit, and the complete record of this Ronit is being mentioned in the form of tuple of roll number 21 and age is 9. And same way, what about columns? So this columns has been given a specific name called as attributes. Attributes. Now let's list out what are the attributes present in this table. First one is roll number, second one is name, and third one is age. So you have three attributes given in this particular table of a student. Now let's get into the topic, little more deeper into the topic. So you see here, what is meant by tuple? Tuple represents a set of related data. That's what I said. You have all the set of related data mentioned in a tuple. And what is meant by an attribute? It is something, an element that contains several records. You see, a roll number is considered as one element and it is carrying out several records of from roll number 21 to 24. Same way with name and age. Now let's look into the concept of degree. So what is meant by degree? So need not look into the sentence, we directly look into the concept here. What is meant by degree in the sense? It is nothing but the total number of columns present in relational database. I already said when I use word relational database, it's nothing but table. It's nothing but a table. So what is a degree here? It's nothing but the number of columns present in a table. Now let's count how many columns I have here. Like how I have counted it in the previous slide. How many columns? 1, 2, and 3. So for this table, I can say the degree is equal to 3. Now next one is your cardinality. What is meant by cardinality? It says cardinality is nothing but the total number of tuples present. Total number of tuples present in relational database. Now let's count how many tuples I have. What is meant by tuple? Tuple is otherwise called as rows. So just count how many rows has been present in this table. 1, 2, 3, and 4. So I have 4 rows present in the table. You should not consider roll number, name, and age. So these comes under attribute concept. We have to count only the entries made under those particular attributes. How many entries are made in the table? There are 4 entries. So I can say the cardinality of this particular relation or table is equal to 4. Let me make things little brief. Tuples are nothing but the rows. Attributes are nothing but the columns. Degree is nothing but the total number of columns present in the table. And cardinality is nothing but the total number of tuples present. Total number of tuples present. Yes, here I'm highlighting the concept here. Total number of tuples present. Let's move on. Let's get into the concept of keys now. I already said keys are a very important concept of your relational database. So, you think when I start adding up the data in a table, or let me say, if I'm planning to create a table with certain set of attributes. So there will be few attributes or few column names which will carry a unique value, For example, consider the data of a student. A student carries a attribute called as roll number. So he carries an attribute called as name, and the details of student also carries an attribute called as age and so on. So among this, there will be an attribute which helps the student table to have a unique value, unique information. For example, you consider here roll number, name, and age. So first let's come from this side. Think of age. Is there any chance of repetition of age in the data? Yes. So more than one student can have same age. So this age is not considered as a unique element. Now look into the name. Can name be unique? No. So name can be repeating. Again, this is not a unique value. Now look into roll number. So in any university or college, we usually assign roll number for each and every student. The reason is the unique identity. So you want the student to be identified uniquely irrespective of his name. So it's very clear that roll number is a kind of attribute that carries a unique value. Now, what about the combination of roll number, name, and age? So, of course, roll number is unique. And what about the combination of roll number, name, and age? Don't you think those are unique? Yes. So, the combination of other attributes along with the unique attribute is also making the complete data as unique. So if you look into here, this person Ronit with age 9 along with his roll number is carrying a unique record. This record is said to be unique. This cannot be repeated again because the roll number 21 is assigned only for one student. Same way, the remaining records are also said to be unique in nature. So one thing is clear. the uniqueness of a table is depending on one particular attribute, which is making the complete data without any repetition, which is maintaining the data without repetition. That means redundancy is being avoided over here. So those attributes which are making the data unique are called as keys or a key. The attribute which makes the data unique is called as a key. In this example, roll number is considered as key. Now, is there any rule like we have to have only one key? Is there any chance of having more than one key in a table? The answer is yes. So we can have more than one key in a table. For example, if I add one more attribute here as an email ID, if I add one more attribute called email ID here, so don't you think email ID is a unique identification? Yes, there's no chance of repetition of email ID from one individual to the other. So even the email ID is going to act like a unique value. So if I consider email ID also for this table, I can say I have two keys for the table student. That's what it says. The keys are used to establish and identify relationships between the tables and also uniquely identify any record or row of data inside the table. So there's one point that's mentioned here, identify the relationship between the tables. So keep this point in mind. In coming slides, we'll be discussing that concept, how the key is going to help me in identifying the relationships between the table. Let's discuss in the coming slides. So let's go move on. So there are different types of keys available in your relational database. First one is super key, next one candidate key, next one primary key, alternate key, foreign key. So let's look into each and every concept of key along with an example. So what is meant by a super key? So super key says it's all possible keys that are available. It is a set of keys with all possible keys. So directly get into the example, then the concept will be clear. I have a table called as student with SID, registration ID, name, branch, and email. So let me pull out all the unique attributes from this table which are called as keys. What about SID? SID is can be considered as a key because it's a unique value. What about registration ID? Yes, this also is a unique value. What about name? No, it's not a unique one. Branch, it's not unique. The branches do repeat for person to person. And then coming to email, yes, email also considered as unique. Now I have three keys here. So what does the definition says? It's nothing but the set of keys with all possible keys. So how many possible keys I have? Three possible keys, and I start making sets out of this one. So how many sets I can make? I can make a set of 2. I can make a complete set of 3 also. So all these combinations what I have tried here are considered as super keys. All the possible combinations are said to be the super key. Next one, what is meant by candidate key? So in your previous slide, the super keys are framed from 3 basic keys. Now I say this is nothing but a candidate key. These are nothing but the candidate key. So what does it mean? It's nothing but the minimal subset of super key, minimal subset of super key. So when I have these many super keys here, I will be decomposing these keys into very less number as possible. So 3 has been decomposed to 2 and 2 has been decomposed to 1. That means the minimal subset what I found here is 1, and that can be considered as candidate key. So here I have SID, registration ID and email ID as my candidate keys. So It says if any proper subset of a super key is super key, then that key cannot be a candidate key. So moving further, see here, I have these subsets and this cannot be considered as candidate key because this has the highest subset and this has a count of 2 because it can be further decomposed. Therefore, I can't consider this one as a candidate key. Next, what is meant by primary key? So see, when I start working on a relational database, I have to consider one key as my primary key. Though my table has n number of keys, but among those n number of keys, I have to consider one key as my primary key. What is the reason? Why should I take one key as primary key? Because this one key, which is called a primary key, is used for dealing with the table, used to deal with the table. So this one key forms an identity, main identity for a specific table. And next question is there any rule for selecting the primary key? No. So among the candidate keys, it's our wish to select. We can it's the privilege has been given for us to select the primary key. Among these three, it's my wish to select any one as my primary key, and that key will be referred to work on this table. So that it acts like a reference to work on the table called as student. So one thing I should keep in mind is whatever key I am selecting should not be a null value. Null value in the sense the attribute has carrying no value. It is neither zero nor carrying any value. So those things should not be encouraged for primary key concept. So that's what it says. It's a candidate key chosen to uniquely identify each row of data in a table. So no two rows can have same primary key values. So it's already clear. So attributes will not be repeated, right? Then obviously no two rows will be having a same primary key. There's only a chance of having one primary key. And any primary key cannot be null. Okay, let's move on. What is an alternate key? So, alternate keys are those keys which are left over after the primary key is selected. For example, in this particular table, I have three candidate keys: SID, registration ID, and email ID. And I thought of selecting SID as my primary key. I thought of selecting SID as my primary key, and the leftover keys, that is the registration ID and email ID, are considered as the alternate keys, are considered as alternate key. So I say it is a candidate key which is not chosen by the database designer to uniquely identify the row. So I am the database designer and I have selected SID as primary key, and the remaining are said to be the alternate keys. So next one is your foreign key. So there's an important role played by a foreign key. So let me explain the concept with an example and then let's look into the sentence. First, you have two tables here, student table and registration, student table and branch table. So you just look into both the table and try to compare the attributes and pull out that particular attribute which is common in both the tables. So I can find the branch code here, which is common in both the table. Branch code, which is common in both the tables. So this branch code in one table, this particular branch code, which is common in student table and branch table, is going to act like a foreign key for the first table. It's going to act like a foreign key for the first table. So why should I work on the foreign key? So for example, you had a query to pull out or get an output whose values are present in first table and also in the second table. So I want to get my final output which is depending on both the tables, that is student table and branch table. In that case, I should look for a relation which is used to join the tables. These two tables should be depending on each other. How will they depend on each other? The dependency happens when there's a common attribute existing between both the tables. When both are dependent, then my data retrieval, my output retrieval becomes easy for me. So let's get into the sentence. It is a single attribute or collection of attributes in one table that refers to the primary key of the other table. So in this particular branch table, this branch code is acting like a primary key, and for this table, this branch code is acting like a foreign key which is linking up the primary key of the second table. Listen very carefully. The branch code in branch table is considered as primary key, and the same branch code in student table is taken as a foreign key which is used to link up the branch table with the student table. Whereas the student carries a separate primary key, it can be a SSID or it can be a registration ID, but this branch code is considered as a foreign key. Now let's get into the concept of relational algebra. So I can say, so relational algebra is nothing but a procedural query language. Procedural query language. In fact, it is not going to be, we are not going to execute this one in our system. We are not going to execute this. This is going to form a basis for writing my queries further. It's going to form like a basics, like in our childhood, we do read the alphabets first and then start framing the words and sentences. Same way. The alphabets are not going to help us much, but those are helping us to navigate to words and then sentences. Same way, relational algebra do not work in real time scenario, but these are going to help us in writing queries in different platforms. So let's see again. A relational algebra is a procedural query language which takes relations as inputs and deals instances as outputs. So it takes the input as stable and gives us the output according to our queries what we write. Output in the sense it can be a table or it can be a single value. It depends on the query what we write. So that's why it says instances. And next one, it uses operators to perform queries. Let's see what are those operators. Keep in mind what operators. So these operators are helpful in writing the queries, and those operators will be discussing one by one along with an example. So let me tell you one thing, this relational algebra mainly helps you in providing theoretical foundation. That's what I was saying. It is helpful in providing theoretical foundation for relational databases and SQL. And this relational algebra is considered, so I already said, let's look into this sentence. The user tells what data to be retrieved and from the data and how to retrieve the data. So there's one point I need to mention clearly is I'm saying this relational algebra as a procedural query language. So in your previous session, we have seen the DML has been divided into two elements. A small glance going back, we are just taking a glance from previous session. DML is divided into two. One is procedural query, procedural DML, and second one is non-procedural DML. So what does it mean? So when I speak about procedural DML, I need to mention here what data I need. At the same time, I should also tell the compiler how to get the data. How to get the data. Whereas when I speak about non-procedural DML, here I have to mention only what data I need. I just have to focus on what data I need, but I need not mention how to get the data. I'm only bothered about what data is required for me, and remaining headache will be taken care by the compiler. So, how is this compiler going to work on your query? So, we have inbuilt codes already written over there, and depending upon your question, so what data you want, you will be mentioning, and depending upon that query, it will start executing. It will look into the matching query or inbuilt query and start executing and give you the output. So this relational database says it's a procedural query language. So it means here you have to mention two elements. One is what data you need, and you should also mention about how to get the data. So relational algebra comes under that category. Relational algebra comes under the category of procedural DML. So I was saying this relational algebra is going to work on operators. So now let's look into the concept of operators. So there are different operators of relational algebra. We'll be looking mainly into this set of operators because these are enough, almost enough to write queries in this concept. So the first one is projection operator. So which I indicate with symbol pi, and selection operator which I indicate with sigma, rename operator which I indicate with row, yes, row, and then cross product, and name itself says you're going to mention with x, and joins, all the joins are indicated with this way. Union operator is indicated by u, intersection operator by inverse u, and set difference by minus sign. So let's look into the application of each and every operator and how the operator works over a table. First operator is the selection operator. So I already said selection operator is represented by sigma. I'll make things very simple for you. Keep in mind when I say selection operator, it is going to work on tuples. Where is it going to work? It's going to work on the tuples. So when I use when I use sigma operator along with some condition, so the tuple which is satisfying the condition will be pulled out, and my data will be displayed. And my data will be displayed. Now you see, let's get into the example directly. Before that, look into the syntax. Sigma P of R. What does it mean? Sigma P is nothing but the predicate. Predicate means the condition what you are trying to put in the table, and R is nothing but the table name. So let's look into the table. Here I have a table called as student provided with attributes SID, SNAME, age, and gender. So here I'm writing my query something like this. Sigma of age is greater than 18 from student S. That means I want all the records, that means the records have to be pulled out from the student table whose age is greater than 18. So tell me what are the elements whose age is being greater than 18? So Ram and Geeta are carrying the age greater than 18. So the records of Ram and Geeta will be pulled out. So here the records you can add SID, age and gender as well in your output. And now I have one more query written, that is the names of so all the records whose age is greater than 80 and gender as male from student is. In that case, I have only one record of Ram. Again, you have to add here SID of Ram along with age and the gender in the output. So all the tuples will be pulled out. So you have to add the elements over here, that is Ram's SID, age and gender. So that will be my output. Next one is projection operator. I already said sigma is going to work on tuples. Now, this particular projection operator is going to work on attributes or columns. The attributes or columns, and it is represented by symbol pi, whereas selection operator used to work on the rows or tuples, which is represented by sigma, whereas pi operator or projection operator will work on the attributes. Now let's directly go into the example. I have the same table, so I'm working with projection operator on the same table. I have SID, name, age and gender in student table, and now I'm writing pi of name and age from student table. That means I want the complete attributes called as name and age to be pulled out from my input table. I want name and age to be pulled out from the input table, and that I'm doing using a projection operator here. So name and age are pulled out and are displayed as my output. So this is how the projection operator works. Next one is a cross product. Next one is cross product. So how is this cross product going to work on the relations or tables? Let's see. So one thing is clear: when you want to apply a multiplication, if you want to take a cross product of elements, so one thing is clear: you need to have more than two relations or two elements. So as we are working on relational database, so let's consider to apply cross product, I need more than one table so that I can multiply the tables. So how is this cross product going to work? I'll explain. Before that, it is represented by cross, which can be predicted. So cross product is nothing but represented by cross. Okay. So that's directly go. Let's go to the example. I have a table called as student and a table called as reserve. Fine. So when I apply cross product or Cartesian product between table student and reserve, what happens means this tuple, that is 1 ram 21, will be combined with the remaining tuples of the second table. So in fact, though I have written here a simple output, let me tell you why the output has come so simple. But in fact, if you directly apply a cross between student and reserve, what happens means the first tuple of the first table will be combined with all the tuples of the second table. That's why the attributes are copy pasted here. SID, SNAME, age, again SID, ISBN and day. Same way, once this combination is over, the next combination will continue. That is, the tuple 2 will be combined with the tuples of second table. Once this is done, again, the third tuple will combine with all the tuples of second table. Once this is over, again, the fourth one will combine with all the possible tuples of the second table. That means each one is combining with the remaining tuples of the second table. Then you can imagine how big the output will be if you apply a cross product. In that case, there's a chance like you may have some meaningless information also added in your output table. Among that meaningless output or meaningless values, those are inserted in the output table, I need to pull out the desired values. So how to pull the desired values or meaningful output from the output table of cross product? That is by giving the conditions. That is by giving the condition. So I gave a condition over here from the output table of student and reserve. I want the reserve.isbn is equal to 005. I want all the records whose ISBN is equal to 005. So here student and reserve. So this is missing over here. Please make a note of this one. Student cross reserve should be in the bracket. Student dot reserve should be in the bracket. And now I give a condition to pull out the meaningful records out of the cross product. That is, I'm getting two values over here. Now, next question. I have an important element to be addressed here. That is this one. Student.sid is equal to reserve.sid. What is this student.sid is equal to reserve.sid? There's one main condition that has to be satisfied before applying the cross product. The condition is when you are trying to apply a cross product, both the tables on which you are imposing the operator should have a common attribute. Both the tables should have a common attribute. Only those tables can be taken or considered for the Cartesian product. So in this table, student and reserve, I have SID which is common among both the tables. So this SID is forming a link between these two tables. That's what we have spoken about a foreign key. SID is acting like a primary table as well as foreign key in both the tables. So that condition should be mentioned here. Student.sid, that means SID of student table should be equal to SID of reserve table. And what is this operator here? The small inverted V operator. The small inverted V operator is nothing but the representation of end, A and D. Representation of end, because you have two conditions that are mentioned here. So you have to join both the conditions using end operator. And what is the sigma? Sigma is going to pull out all the tuples out of the output from student and reserve cross product. So ఈ అవుట్పుట్లో నుంచి you will be getting out the desired tuples out. Desired tuples out. So this is all about cross product. Now let's look into the set operations. So different set operations what we are going to see in present session is the union operator, intersection operator, and next one is set difference. Okay, so how is this union operator going to work? I'll make the concept very simple. Union operator can be otherwise considered as OR. So when you are applying the operations, again I have to work on two tables or more than one table. If I'm applying the operation set operators, again I have to have more than one table. In that, if I use union operator, I'll be satisfying OR condition over here. What I mean to say is if you find your questions or queries having OR condition, then go for union operator. If you have your queries having OR condition, then go for union operator. So it is represented by U. So what does it say? This operation is used to fetch data from two relations. What is meant by relation? Relation is nothing but the table. It is used to fetch the data from two relations. Next one, for this table should have same number of attributes. For this table should have same number of attributes. This is one condition that has to be satisfied. And now you look into the query written over here. Sigma, pi of author from books union pi author. So what is this author? Author is nothing but the attribute name. Pi author from table article. So how is this pi going to work? Pi is going to work on the attributes. So it's going to pull out the author column or attribute from table called as book, and it is also going to pull out other author column from the table called as articles. Now you have two columns and this one you are applying your union operator. So what data you will be pulling out? So it will pull out the names of, so you have two outputs. So you have one output from this query, second output from this query, and for both the outputs you are applying a union operator. Now you should be getting a final output here. So what final output you are getting here? It's nothing but the names of the authors either written a book who has either written a book or, focus, you have or here, or an article, and again or both. This is the condition, or both. So you have or condition over here. That means the authors who has either written a book or written an article, or in case he has written both, all the data will be pulled out, and that will be my final output from these two tables. From these two outputs, output 1 and output 2, from those I'll be getting my final output, which is satisfying or condition. Now let's look into the concept of intersection. So you see, intersection is represented by inverted U, and now for intersection you consider the term and. Consider the term and. Consider the term and. Now you see here, I have sigma of author provided with books, and I have applied an intersection operator, and again sigma of author provided with articles. So what is going to happen? For this particular query, I'll be getting all the author names from the table book, and for this particular query, I'll be getting another column of author from the table articles. So I have two columns over here. For this, I'm applying an intersection operator. And what output I'll be getting here? I'll get one single output of authors. I'll be getting the output of authors who have written a book and article. So I'll be getting only those authors who has written a book and also an article. So you have a query here having end condition to be satisfied, and that is said to be my final output. So this is about the set operations of intersection. Now let's see what is the set difference. So set difference has to satisfy not condition. Set difference has to satisfy not condition. For the same example, if my scenario is something like this, find the data of the authors which has written a book and not an article. That means I want the data to be present only in one table but not in the other table. If I want the data present in one table but not in the other table, then I have to go for not operator. You see here, it is represented as R minus S, not in the sense minus symbol, R minus S. So if I write my query something like this, projection of author from books minus projection of author from articles, in that case I'll be getting only the names of those authors which are present in book and not in the articles, which are present in book and not in the article. Okay. Next one is rename operator. So this rename operator is represented by row symbol. And you know what is the purpose of rename. If you feel like you want to change the name of a relation which is existing, in that case, or if you want to change the name of the relation temporarily, in that case, you go for rename operator. Look into the syntax directly. Row of x in brackets E. What is this x? X is nothing but the new name what you are trying to impose on a relation, whereas E is said to be the old name. E is said to be the old name, where small x is said to be the new name. So this is about the rename operator. Now let's get into the concept of joins. So let me tell you, the concept of joins are very close to the Cartesian product concept what we have seen just now. And we have seen in previous example, like when you have applied a Cartesian product between A and B, you had a big output table with all the combinations. And to get the desired output from the Cartesian product of A and B, I've imposed a condition over there. I've set two conditions over there to get my output. Let's look in here. So you see here, I've imposed a condition that the reserve.isbn should be equal to 005. Only though that data I want to pull out. That means I'm giving a condition over here to a cross product of student and reserve. In that case, I got my desired output. Same concept if you are trying to impose a condition in your sigma operator for a Cartesian product, that is nothing but join. If you are imposing a condition to a sigma operator for a product of A and B, that is nothing but a join. I can simply call it as a conditional join. Let's call it the conditional join. So how you represent a join? Join is represented by the two triangles facing each other. So this type of elements, and I've mentioned an important condition that has to be satisfied. What is that condition? If I want to apply Cartesian product between two tables, I need to have a common attribute. Same way, for join also, if you are trying to apply join between two relations or two tables, in that case, you have to check for a common attribute. Now the question arises, what if there's no common attribute between two tables, but I want to join? Join is a join. When should I go for join? When I want my data to be retrieved from both the tables. Sometimes it happens like some data will be present in one table and some sort of data will be present in the other table. And if you want to retrieve the data from both the table, the only option left is you have to join the tables. So how to join the table? The condition should be satisfied, same attribute condition. What if there are no same attribute present in both the table? Then check for the third table which is carrying the common attribute of table 1 and table 2. If you find that such kind of third table, then indirectly the relation is existing between first two tables also. Let's see the concept, that kind of concept in coming sessions. So I said this conditional join is nothing but the Cartesian product provided with a condition or a predicate in your sigma operator. So equijoin condition. So equijoin condition is nothing but if your condition is carrying something like equal symbol. So you have here a book and reserve and you are provided with ISBN provided in both the tables and same set of attributes and same set of values present. So if you are imposing a join between this kind of table, then that is said to be an equijoin. That is said to be an equijoin. So again, when first cross product is taken and all the tuples will be combined with the tuples of remaining tables and all those combinations will be registered in my output, and depending on the final condition what I give in the sigma operator, depending upon the final condition what I mention in sigma operator, my desired output will be pulled out. And equijoin and natural join comes under the same aspect. So in our coming sessions we'll be looking into the concept of entity relation diagrams. So entity, yeah. So there's one more operator that is left over, that is division operator. So the division operator works on all conditions. This division operator works on all conditions. I repeat, intersection union works for and, intersection works union works for or, intersection works for and, set difference works for not, and division operator is going to work on all conditions, and it is represented by the slash. So let's get into the details present here. I have two tables called as customer and an account. So I want to find all the customers having account in all the branches. I want the list of the customers which are having their accounts in all the branches, and if I apply slash, Look into the first table. Literally speaking, you just analyze the output over here. The first one in table customer, which customer is carrying having account in all the branches. So I have two branches over here. One is Pune and Mumbai, and I want to check the names of those customers which are having names of those customers who are having their account in all the branches. So you see, it's only the customer A is who is having account in both Pune and Mumbai, and my output will be A. This is how the division operator works. So, in coming sessions, we'll be looking into the concept of ER diagram. So, what is meant by an ER diagram means an entity relation diagram. So, this is something which is done like this, which happens like a framework before getting into the database design. We do a paperwork like making a design or design using some symbols or representation to proceed further with the database design. Let's get into those concepts clearly in the coming session. That's all for today's present session. So we have looked into the concept of keys, what are the elements of database, relational database, set operators like union, intersection, along with set examples. I think the concepts are pretty clear in today's session, and thank you.